The final countdown. Your last presentation. All right, let's go to the practice final. There are 10 questions on this. There will be a bonus question on the exam. That is not listed here. First thing I should do is what? Who's gonna fuck this up on test day?
Put your name on.
Put my name on it. That damn Skippy, that's what you do first. El Jefe. All right, then what do I do? Read the instructions. To receive full credit, I must be able to read and follow your work. That supports your answer, not just pretty art that doesn't support anything. Each question is worth 40 points. Ooh, a whopping 40 points. Doesn't matter. You can look on the syllabus and know exactly how much the final is worth. Making each question worth 40 makes it so that I can penalize a stupid mistake like a plus or minus with only one, and 1 out of 10 questions at 40 each is 400. Missing a single point for doing a plus or minus out of 1 out of 400, you still have like a 99 point something % on the test. So the more points I make each question work, the easier it is to like not penalize steeply for silly shit. All right, so what are we doing on this first one? Graph this, find the eccentricity and foci, and state the domain and range. I know the things that have an eccentricity and foci plural, there are two options here. There are the ellipses and there are the hyperbolas that have these. Which one is this one? It is a hyperbola. Why? The minus sign tells me it's a hyperbola. Excellent. Am I going to open up and down, or left and right? Up and down. Why? Well, the y is the positive one. The x is the negative one. We want the positive one, so that's the direction we open along. It will intersect the y-axis. Guaranteed. Guaranteed to intersect the y-axis. The other one, depending on where the center is, may or may not intercept the x-axis, but you're guaranteed to intercept the axis of the one that's positive. All right, so it says graph it, which means I need a couple of pieces of information. I need the center. If I could write the word center, which is what? It's what? It is 3, -4. Remember, just because the 4 comes first, it's associated with a y. It's got to go in the y spot. So we got 3, -4. And what do I do with the 16 and the 25 here? Gives me my A and B. Say it again. Okay. So I get, which one is, there's 4 and 5, which one's A and which one's B? Okay, yeah. All right, I'm gonna need my foci. My foci are, how do I find the foci?
Square.
C squared equals A squared plus B squared, and the foci are along, or what do I do with this value when I get it? Let's see, what do I got here? C squared is 25 plus 16. So C is the square root of 41, which is about 6.5, maybe 6, a little bit below. What do I do with that? Might be easier to graph first before we decide what we do with this. So let's start sketching. I want a center of 3, -4, which means I got more going on in this lower right quadrant than I do anywhere else. So I'm going to emphasize more of my graph in that region. And I don't know how many up I'll need to go. So I'll put a few on there. So I will put my center at 3, -4. What do I do with that piece of information? I do. What made you decide to do that? Okay, and B is 4, that's why you said go up and down 4. 2, 3. I'm clearly not lined up underneath my fucking 3 very well, am I? I should have a point there. That's up 4. Down 4. Is right there. And you say, what do I do with 5? Left and right 5. 1, 2, 3, 4, 5. So along -2, right about there. And 1, 2, 3. 1, 2, 3, 4, 5. All right, I did that. Well, now what do I do? Make my cross? Okay, so we make our cross doing the box. So I find where these would make. If I go straight up and straight down, left and right from those 4 points. I get those values, let's see, line it up there. A little bit higher, there we go. And okay. It's hard to draw a straight line when I'm not doing it away from me or towards me. But that looks about good. All right, now what? I draw my hyperbola, right? And we said it was going to go up and down, and it has to go towards the asymptotes. That's what asymptotes do. Nice little rounded thing. They don't look like arrows, not pointed. It's got a nice curve to it. All right, so I got that. Now what? Now what is? Does that help me with my foci, my C? What do I do with those? I do. Why? It is C away from my center, and it is along that axis right there. So I got to go C up and C down. So my center was 3, -4. So my first foci, as he was saying, I should add square root of 41. And my second one, I should subtract the square root of 41. Those are the foci. If you want, when you want to put them on there, you can approximate it with the 6.5, but you want to actually have the exact value for the foci when you do it. So those are the numbers we're looking for the coordinates. To plot them, I'm just going to go, that was about 6.5, so -4 plus 6.5 is about 2.5. So that would be my F1. And -4 minus 6.5 is about -10.5, which is down here. That would be my F2. How do I find eccentricity? The major or the transverse value one, which is what here? It's not 5. It's 4. It's over the B, the major, the transverse axis right here is the one we're going along. And so that'll be the 4. So we got square root of 41 over 4. I'm gonna put it down here where I can see a little bit better. Square root of 41 over 4, that's enough. If you really want to see a decimal value, knock yourself out. That's kind of like what I'm looking for. We don't draw anything, we don't plot it, so like it's just more work. To find. And what else did I do? So let me reread the problem, make sure I did everything. It said graph it, I did that. I found the eccentricities right there. I did the foci coordinates. I need to state the domain and range. What is the domain and the range? The domain is all real numbers. You can do that, or you can do negative infinity to infinity. Each person has their own preference. What about the range? Looks like -8, yeah. There we go. That looks good. All right, it asked me to do a bunch of shit. I want to make sure Professor Jones sees some of the stuff that is important that he asked for. I'm gonna put a box around that, put a box around E. And I'm gonna put a box around the foci, because that's what he asked for. The graph, if he fucking misses the graph, you have an incompetent teacher as it is. But the easier you make my job, the happier I am when I'm grading exams. And the happier I am grading exams, the more lenient I am on stupid mistakes. So you want Jones being happy. Make it easy to find your shit. The happier I am, the easier everybody gets happier. It's like it's better for everybody. Now, having said that, if you just tank it and you get a 0, you don't do anything, it's not going to save you. But it makes small mistakes worth less when I'm happy. All right. Did anyone need that up longer? All right. Let's solve this. What can I do here? I get a common base. How can I do that? This is excellent. 1 over 16 is 1 over 2 to the 4th power. And I want it as a 2, so I can write that as 2 to the -4. And then I'll slap the x minus 3 back on. And I got 2 to the 2x plus 1 here. Now what? That was a great start. If I distribute the -4 to the x minus 3, I have -4x plus 12 there, and here I have 2x plus 1. Okay, that looks good to me. Now what? Like I'm letting other people answer.
I just work on the up to right.
Yes, we'll work on the up ones. They're called exponents.
I was thinking
If the bases match, the exponents match. That's the idea. If the bases match, the exponents have to match to be equal. Wow, now this is just some simple algebra. I personally like having a positive coefficient. So I'm going to move my x's to the right. And if you do it in 2 steps, you're more than welcome to do it in 2 steps. I tend to hate writing things over and over, so I move the constants at the same time. If I move the x's to the right, I move the constants to the left. This case by subtracting the thing on the right over. And I bring my equal sign down, and I got 12 minus 1 over here is 11. And 2x plus 4 equals 6x over here. Ah, this is not a very nice number, is it? I'm getting x equals 11 over 6. Did I screw something up? Maybe it's just an ugly answer. Well, I can check it. Does sticking 11 over 6 in here give me the same value? -4 times 11 over 6 plus 12. I think I'm going to need to multiply that by 6 over 6 as well to get a common base. Does that equal 2 times 11 over 6 plus 1 times 6 over 6? Here I got -44 over 6 plus 72, which is 628. 28 over 6. And do I get 28 over 6 on the right? I got 22 over 6 plus 6 over 6. I do get 28 over 6 on the right. So even though it's an ugly number, it is the right number. And now that I see that, I feel pretty good about boxing that shit and saying, Jones, you're a prick for giving me a weird answer. It's hard to check. Any questions on number 2? All right. What about number 3? So I want to end up with things that are written log base 3, but I only want to have ones as exponents. Well, the first thing I see is I got an X on top and bottom, right? Maybe I should clean that up. So I'm going to clean up the X's first. What do I do with this X to the 7 and X to the -4? What does that simplify to? What? No. Close, you have the right idea. When we have one number over the other, we subtract exponents. 7 minus -4 is x to the 11th. The negative sign threw you off. So I can rewrite this as x to the 11th. What do I want to do with that y to the -4? We could put it in the denominator and make it positive. We don't have to. There's a couple ways to do this. Maybe I'll look at the other way in a second. Z is already positive down there. Oh, now they're at least positive. Now, how do I break this MF'er up? Because those don't have exponents of 1. So one of the properties of logs was things that are divided become things that are subtracted. I'm dividing by y to the 4th and I'm dividing by z squared. And final step is things that are exponents can come out front. So this should be 11. Maybe I'll use ones like there that look like that. Log base 3 of x minus 4 log base 3 of y minus 2 log base 3 of z. Reason why things that get multiplied get added, things that get divided get subtracted. I could technically write this as y times y times y times y and just do minus log 3y one at a time. And there would end up being 4 of them. And I could do minus log 3z 2 at a time, and there'd be, or 1 at a time, and there'd be 2 of them. I could do this when things are multiplied together on top, it's added. So I could do log 3x plus log 3x plus, and there would be 11 of them. This ends up being the answer we're looking for. Now, I'm gonna go back where we back to what we had here. We simplified the x to the 11th. Well, let's say you didn't simplify the x to the 11th. Let's say you just started breaking shit apart right here. That's not a y, that's a z. Things that are on top that are multiplied together can go in their own parentheses with a plus between them. And then things that are at bottom, they get subtracted. Minus log 3 of x to the negative 4 minus log 3 of z squared. So this is an alternate way of getting the same answer. I pull the exponents out. I'm gonna move this minus down here because that's confusing. So I have 7 log 3x minus 4 log 3y. Pull the negative 4 out front times the negative makes that a positive 4 log 3x. And then minus 2 log 3z. And finally, you'll see you have 2 things that are log 3x. You add them together and you get the 11th. Any questions on that one? That problem is probably the fastest one on here. As long as you remember the rules, it's pretty straightforward. It's not a lot of work. It's just memorization of rules, right? The actual math is a joke. This one, however, has a whole page for it. That's never a good sign. If I give you a whole page to do the problem, that's bad. That's a big red flag. That means there might be more, well, a lot of work here. So if you do this super duper quick, you probably did it wrong. All right, so what can I do here? We could, but then we have a bunch of things added together and the natural log of it isn't going to be very nice. We could do a thing with a u. What are we going to do with the u? What's the goal of using the u? The goal is to make this look something like a quadratic. AU squared plus BU plus C equals 0. So then we can use the things that we do with quadratic stuff. So if I do that here, it looks like U has to equal e to the x. Which means if I square U, I'm squaring e to the x, which is e to the 2x. And that is what I have right there. So I can do that. I'm going to use U equals e to the x as a substitution. If I substitute that in, this becomes 2u squared plus 7u minus 15 equals 0. Now we can do quadratic stuff. You are free to choose however you like. I think quadratic formula takes me the longest to do. I need things that, if I want to factor it, things that multiply to 2 times negative 15, which is negative 30, but add up to 7. If I do 10 and negative 3, I will get that. Bless you. So if you do this, you should still get the same answer as using the quadratic formula. I just like factoring. You can't help it. So here I can factor out a 2u, and I'm left with u plus 5. I should have another u plus 5 over here to get it to work right. And to get that, I had to take out a negative 3. Bless you. So when I finish doing that, I got 2u minus 3 times u plus 5 equals 0. And note that I do keep writing equals 0. It is an equation. We are trying to solve something. We're not just factoring it for fun. Because at this point, that tells me I need to use that 0 property rule. Set this term equal to 0 or this term equal to 0. And if I solve for u here, I get 2u equals 3 and u equals 3/2. Or I subtract the u over and or the 5 over and I get u equals negative 5. Now what? Am I good? I got to put it back in, right? I didn't start with you. I can't end with you. So I'm going to make that replacement. I'm going to put it back in. Which means this gives me e to the x equals 3/2 or e to the x equals negative 5. It's fun when my hair gets long. It feels no matter what I do with a brush, it always looks like I brushed my hair with a balloon. You know what I mean? It's just all. I need to get a haircut big time. All right. I still don't have X. How do I get X? Well, I don't have how? I need to finish first. Now we do the natural log. So we'll take the natural log of both sides. And give myself a lot of room to write there. Natural log of e to the x is x equals natural log of 3/2. And over here I got x equals natural log of negative 5. Those look like the answers. Are they? Only the positive one's gonna work. Why? Can't take a log of a negative number. And we could have seen this right here when we had e to the x equals -5. If you remember the graph of e to the x, it goes like this. It's always greater than 0. It's never even equal to 0. It's always greater than 0. So this one doesn't meet greater than 0. That's out. And if I want, I could check this here. I have 2e to the 2x equal or plus 7e to the x minus 15 equals 0. If I plug this in, I got 2e to the 2 ln of 3/2 plus 7e to the ln of 3/2. Starting to get ugly. This is, I could put the 2 up as an exponent. 3/2 squared. Plus 7e to the ln of 3/2 minus 15 equals 0. And now the e and the ln cancel out. And I'm checking my work here. This ends up being 9/2 for that one right there. This one is 21/2 minus 15. Does that equal 0? This is 30/2 minus 15 equals 0. And yes, that's going to give me 15 minus 15. So it's not the prettiest cleanup, but it sure as hell did show me that I got it right. So, Mr. Jones, we're gonna box that motherfucker and make it easy for you to find. You know, the one thing that sucks about finals being next week? Fucking new Zelda arrives tomorrow. And I don't want to play it. Don't want to start it till I get all the grades done and entered. Because then if I start playing Zelda, I'm going to procrastinate that shit and enter them on May 26th, trying to rush it at the end. I'm going to have students emailing me going, what the fuck? We took the test 10 days ago. Where's our grade? So I have to just look at the Zelda box sitting there. It's not fair. I blame you for being enrolled in college. You guys ready for more? All right. How we doing online? Everyone online doing good?
Yeah.
I'm good.
Paxton, that was the most yeah I've ever heard. That was not good. Okay, so let's go for it. What can I do here? We can raise these as exponents to the 2. We need to do something first because the plus sign right there is fucking it up. Actually, technically it is. It really is. But I don't want you to, that you definitely make a mistake if you do it that way. There's something we can do before that. And we just went the other direction a little while ago. So we took things apart we can put them together. Things that are added become things that are multiplied inside logarithms. I will show you what raising it to the power of 2 would do at the end. Because it is doable. Okay, so we can do the raise it to the power of 2 now, or the other result is if I do that, the 2 and the log 2 cancel out. And I have x plus 4 times x minus 6 equals 39. The other way to look at it is if both sides are logarithm of base 2. And we have an equal sign, then the things on the inside of the logarithm have to equal each other too. Otherwise, this won't equal each other. Either way, this gets us what we wanted. What do I do with that? Can I say x plus 4 equals 39 and x minus 6 equals 39? Why not? It's not 0. That rule only works if there's 0 on the other side. Excellent. So that unfortunately means what? We got to distribute, multiply this shit out. And I can move the 39 to the other side at the same time by just saying minus 39 equals 0. But you don't have to. You could say equals 39 and then clean it up and then subtract the 39 over. But we definitely want to get everything on the same side. If I do that, I have x squared minus 2x minus 63 equals 0. So either quadratic formula or factor. 63 is fucking really easy to factor because there's only 2 combinations to make a 63 through multiplication. 63 and 1 or 7 and 9. I will have a 7. I will have a 9. And I need to put signs in there such that I end up with a -2 when I'm done. If I add them up, if I do -9 and +7, so -9, +7, those multiply to -63 and they add to -2. So that is right factorization. Now we have the right side equal to 0. We can separate this bad boy up into 2 equations. And I get x equals -7 or x equals 9. Good. Any questions?
That's the one. That's the spelling. Let's do the answer.
Okay, good. I was waiting to see if someone said it. We gotta check them, right? Don't just assume it's gotta be positive. Let's look inside the original things. We need to make sure the insides are positive. We had an x plus 4 and we had an x minus 6. If I stick in -7, these both end up negative. Then I've got a negative inside a logarithm and we don't want that. That would be log 2 of -3 and that would be log 2 of -9 and that is a hell no. So -7 is out. Let's look at the 9. I have log 2 of 9 plus 4 and log 2 of 9 minus 6. That's log 2 of 30 or 13 plus log 2 of 3. Those are both positive. That'll work. Now you could check them and go, really? Log 2 of 13 and log 2 of 3 equals log 2 of 39? You could check it, you can plug it in, Or you can use those properties and multiply the insides. And 13 times 3 is 39. And that's the right side.
Couldn't you? I wasn't paying attention to the last part, but couldn't you just do the? I was writing down, couldn't you just do the x plus 4 times x minus 3 and plug each of them in to see which they 39?
No. You don't always want to do that, because if you start with them at this step here. If I stick in -7. I have -3 times -13. And that would give me a positive 39. So if you start at the step here, it works. You start at the starting point where we started, it doesn't work. That's very important. And the reason why is we did some exponent manipulation to get here. And whenever we do that, if we square things, we square root things, there's a chance we introduce bad answers. So never go with the second step. Even if I did it on, do you guys see that? If I stick in the -7 here, this actually works. I get log 239 on both sides if I stick the -7 in here. Right there. So you do not want to start at even the first thing you did. Check it in the initial equation. That's an excellent question. So, having said that, I decided x equals 9 was the answer. Maybe I'll come down here and put it in the corner and box it. Or I could have boxed it up here, but it's pretty easy to find if it's in the bottom of the page and box. And a happy David is a good thing. Yes.
And on where it says x equals 9 and you do the whole log base 2 and then it's 4. You get log base 2 of 13 plus log base 2, 3. Reason why those equal 39, you can multiply that.
Yeah, I did the same, the way I put them together up here, I did it here. You could stick this in a calculator. And when you add them up, and then do log 2 of 39, you should get the same decimal answers on both sides. All right, you guys ready for more? All right. Graph 9 not 9. There's not even fucking 9 on the problem. Graph y minus t squared equals 4 times x minus 3. Find the coordinates of the vertex and the focus. Include the directrix on your graph. State the domain and range. Well, vertex and focus and directrix are telling me this is a parabola. What do I do with that? I know it's a parabola now. What pieces of information do I need for a parabola? Dumped everyone. Excellent. Okay, well, first off, is it a parabola going left and right, or is it either left or right, or is it a parabola going up or down? Easiest way to remember is go ahead, see what you got. Hit me with it. You think it's going up? Okay. What is the one basic parabola we know that is going up? What's the equation for it? Simplest parabola I know that goes up. Y equals x squared is the simplest parabola I know that goes up. Am I in that format? No. My x is squared here, but my y is squared here, which tells me I am not going up or down. So it's a good try. But this is a good way to check. Does that make sense? So I know it's either going to be left or it's gonna be right. How can I tell which way it's going? If when all the constants are gathered together here, and if this is positive, it's either going up or it's going right. Since it's with the one that's going left or right, it's going right. So I know it's not open to the right. Yeah,
It doesn't, it's not flipped, it's like if it's a positive number, it goes down,
if it's, what do you mean flipped?
like. There's that 4 with the negative, I thought.
Yeah, it was, yeah, that's why I'm saying if it's positive, it does this. If it's negative, that number is negative, it's either going down or it's going left.
Yeah, I thought it was the other way.
Oh, no.
What?
The things that flip are the things that are inside the parentheses. So this is in the form y minus k squared equals a times x minus h. So what's my what's my center? What's my vertex here? Three comma two. I like that. How did you get that?
It's like stage. H is new, so it's probably. And K is 2.
Just match those out, right? K is 2 and H is 3, and we know it's HK, right? Excellent. All right, so, well, let me just start down a little sketch. I know it's opening to the right. So I'll include more that way. Now, if you didn't recognize that right away, and you didn't know if it went left or right, hopefully you get the center. A good thing to do is to find intercepts to graph. So let's find intercepts. If I look for the x-intercept, at that point y equals 0, and my equation becomes -2 squared equals 4x minus 3. So 4 equals 4x minus 3. I could distribute, but I like what I see here. If I divide by 4 right here, I just get 1 equals x minus 3. And I get x equals 4. So I have an x-intercept at 4, 0. Jesus, that hits it right away, doesn't it? Right away. So I can already tell that it should be opening to the right because that is to the right of the graph. And using symmetry about the axis of symmetry, I went down 2 and right 1 to get this one. I can go up 2 and right 1 to put 1 there. And that, I'm good. That's enough for Mr. Jones. Had you checked the y-intercept first, if you've done the y-intercept first, x equals 0. And if x equals 0, I have y minus 2 squared equals 4 times -3. Or y minus 2 squared equals -12. And if you try to take the square root there, you get a complex number. This is complex. So it means there is nothing on the, it does not hit the y-axis. No y-intercept. That's a little side note. If you'd done the x-intercept first like I did, which was convenient, you would have seen that as got open to the right. All right, so my vertex, we did that one. We need to focus. How do I find the focus? How do I find the directrix? So the focus and the directrix came in 2 flavors. If we have it listed like we do here with either y minus k squared equals a x minus h, or if we had x minus h squared equals a times y minus k, in both of these setups, we can set a equal to 4p. In this case, my a is 4. So I have 4 equals 4p. Which means divide by 4, I get p equals 1. P for the parabola is like the c in the other two, the hyperbolas and the ellipses. It's the distance from the vertex, the center. So, and that tells me I gotta go right one here, and it could just so conveniently lines up right there. This is P to the right of the vertex. So my vertex was 3, 2. My focus is 1 to the right of that, which is 4, 2. What about the directrix? What is the directrix? This is that tricky sense of bitch. It's not like the ellipses and the hyperbolas. This is the variant one. So any point on the parabola is equally distant from both the focus and the directrix. The directrix is a line that is P the other direction. That is the directrix. So the directrix here is along x equals 2. Directrix is such a great word. I love that word. How often do you see words that end in ix? Not many. What do you got? Dominatrix. What else you got? Is there any other words that end in ix? Netflix. Netflix is good. All right, so he wanted the directrix. Included the directrix on my graph. I did. That's my directrix. Maybe I'll label it. He wanted the coordinates for the vertex and the focus. I'm just going to rewrite them so that they're all together so he doesn't have to go look for it, because I want Mr. Jones to be happy. If I don't have room on the paper, I'm not going to force it, but if I do have room on the paper, I'm going to do it. What else does he ask? I did the vertex, I did the focus, I graphed it, I got the directrix, domain and range. Okay, so the domain is what? It starts at 3 and it keeps going to the right, right? And we are including the 3, so we're gonna put a parenthesis, or a bracket there. What about the range? It's all real numbers, so either the all real number fancy symbol, or you could do the negative infinity to infinity. I've got my graph up there. Maybe I better say that this is X and say this is Y, just to make it clear. And I've checked off everything that he asked for, so, and I very kindly put it all in one spot for him to find, because I want Mr. Jones to be happy. Happy Mr. Jones is a generous Mr. Jones. A happy Hefe is a generous Hefe. Any questions on that one? All right. Ah, fuck, synthetically divide. God damn, that's been a while, hasn't it? It has been a while. How do we synthetically divide? We do, we write down all the coefficients. What do I do with them? Put them in a box. Well, now what? I got them in a box. Put a -2 up front. Close. It's the opposite sign here.
Other that one, that was always pretty-
Yeah. The way to think about it is x minus 2 equals 0. So we're looking at x equals 2. That's the value we're trying to divide in. I think that's right. Am I fucking tripping out? The good thing about having my modules open right here is I'll go look. And go, am I talking shit out my ass? I could be. Jones does shit like that. Jones talks out his ass. Where the hell did we do this? We did this in there it is, synthetic division. Looking at it. I don't want that one, that's a video.
Yeah, I think it's the opposite. That's what I was reading.
It's the opposite. Like I did.
Yeah.
Yeah. All right, now what do I do with it? So the first one we had just bring down. You had me all second guessing myself. I knew it was the opposite sign, then I saw somewhere. I said, am I tripping? I could be tripping. I make mistakes. It happens. So I multiply and I do what? Okay, now what do? I add down. And now what? And add down. Okay, so what does this give me? So what we were being asked was, the question was this, basically. This gives me the coefficients of a polynomial 1 degree lower. 3x plus 2. And the 1 at the end is the numerator of the remainder. Plus 9 over x minus 2. That's actually the answer. How can I check this if I've got some time? If you want to check it and you've got some time, take the 3x plus 2, like that, you take your answer, and multiply it by that denominator, x minus 2. I'm gonna put this in parentheses because I think it's a little bit easier to do it that way at first. If I distribute it, I get 3x plus 2 times x minus 2 plus 9 over x minus 2 times x minus 2. And we can see if that goes away. And I can distribute here. And I get 3x squared minus 4x plus 5, which is what I started with. So that is the right thing. Ready for more? I didn't really need a lot of space for this problem. A lot of this was just done with the check. So I tricked you by having a full page. The reason why I gave a full page on this synthetic divide one is because people half the time don't fucking remember and they fuck it up if I don't give them enough room. They start erasing shit and then erase like half-ass erasing and writing. It becomes really hard to read what's going on. I give enough room and you fuck up, you just cross everything out that you don't like and write fresh. All right, you guys ready for number 8? Find all the possible rational roots of the following function. Bonus credit, factor. F of x equals 8x cubed plus 18x squared plus 3x minus 2. All right, when we do all the possible rational roots, we are doing that P over Q bullshit. Q is the coefficient of the first thing and P is the constant. So I want all possible combinations of P over Q, the factors of P over Q. So what might help is to write the factors of P, which is only 1 and 2. And we can do plus and minus on any of these. And for Q is 8, I can do 1 and 8 or 2 and 4. 1, 2, 4, 8. So if I do I just go through them one at a time. I start with the 1. If I do the 1 for the P, that gives me the possibilities of plus or minus 1 over 1, which is still just 1. 1 over 2, which is plus or minus 1/2. 1 over 4, which is plus or minus 1/4. And 1 over 8, which is plus or minus 1/8. And then if I do the 2's, I got plus or minus 2 over 1, which is just plus or minus 2. Plus or minus 2 over 2. And I'll just write these out and I'll simplify in a second, just to make sure everyone's on the same page before I start going what matches up. What is 2 over 2? 1. This is just a 1. And I already have plus or minus 1 up here. I'm going to cross that motherfucker out. I don't need it twice. What's 2 over 4 simplified to? 1/2. And I've already got that. So I can cross that bad boy out. What about 2/8? 1/4. And I already have that one, I can cross that one out. This answers the question. All possible rational roots are those. But that's not why I gave you a full page. For the ambitious folk, the ones that want extra credit on the final. Let's do the extra credit, the bonus. What I'm gonna do is I'm gonna sort these from high to low. -2 is definitely the lowest number. And then -1. And then -1/2, -1/4, -1/8. +1/8, +1/4, +1/2, 1 and 2. And then I'm going to take advantage of some rules that we had. How many sign switches do I have in this thing right here? So we've got f of x equals 8x cubed plus 18x squared plus 3x minus 2. There's only one sign switch, right? From the 3 to the -2. One sign switch tells me at most one positive answer. And if I stick in negative, I have 2 sign switches. So at most 2 negative. I got a better chance of finding a negative number than I do a positive number. So I'm going to check negative numbers. And I'm going to just check -1 to start with. So does -1 go in? Make sure I'm not fucking this one up. Do I need to do a sign switcheroo here? I don't think so. No, yeah, these are the possible rational roots. These are after the x equal. These are x equals possible roots. So the sign has already been switched. All right, does this work? Look at that. I fucking got lucky. -1 is a root. X equals -1 is a root, which means if I move the 1 back over, I got x plus 1 equals 0. That's a factor. So I've got it down to f of x equals, well, this gives me the coefficients of the next smaller polynomial. I have 8x squared plus 5x minus 2 times x plus 1. So we're doing that to get those.
I have a question.
Yeah,
So the original thing is 8x cubed plus 18x squared plus 3x
son of a
minus 2.
bitch.
I was about to say, I'm like, I did not get that one. And I was like, oh, there it is. He has a 13.
God damn it.
17.
I fucked it up. Thank you. That means this doesn't work. God damn it, that's disappointing. All right, so that wasn't right, so. These were all, no, they were not positive, so it might be one of the other ones. Let's try. Fuck it, -1/4. All I gotta do is find one. Damn it. That didn't work. So -1/4 or didn't work. -1 didn't work. Let's try the next one. 1/2 is easier, although I'm guessing that's probably not gonna do it. Oh. Oh, there it is. There it is. It's the -1/2. Yeah, I fucked that up. No,
I
I
don't think
didn't.
so.
All right, so x equals -1/2 is a root, which means x equals or x plus 1/2 is a factor, and that's kind of lame. We don't have fractions in the answer, so I'm going to clear the fraction by multiplying by 2, and I've got 2x plus 1 equals 0. That's going to be a factor. Is it? Actually, I'll multiply through by 2 in a second. I've got this right here. 8x squared plus 14x minus 4 times x plus 1/2 equals 0. This is where the 2 comes in. I'm going to factor out a 2 out of this bad boy. This is 2 times 4x squared plus 7x minus 2. And then I've got x plus 1/2. I don't need the equal 0, that wasn't part of it. And I'm going to take the 2, I'm going to multiply it into there. And I've got 4x squared plus 7x minus 2 times 2x plus 1. Now I'm almost done. I don't need to do this synthetic division anymore because I got a quadratic. I'll just do regular factoring things. Things that multiply to -8 and add to 7 are 8 and 1, -1. So 4x squared plus 8x minus x minus 2 times 2x plus 1. This is 4x times x plus 2 minus 1 times x plus 2 times 2x plus 1. And finally, we get 4x minus 1 times x plus 2 times 2x plus 1. That is f of x, and that is factored. And I'm feeling pretty good about it. If I really want to check my work, I can multiply it all out, right? And get it? But a handy thing that you might want to check right away is, do I get the first number, the 8, and do I get the -2? The way you check is just multiply all the coefficients of the x. If I multiply all the coefficients of the x, I've got 4 times 1 times 2 is 8. So the 8 is good. If I multiply all the constants together, -1 times 2 times 1 is -2. I'm off the screen. I get that. So multiplying these together give me the -2, and multiplying these together give me the 8 that's in front. So I'm thinking that's gonna be correct. But again, if you wanted to check it and you have room to check it, multiply it out. That was fun, right? Not really, right? This is less fun than my favorite topic. My favorite topic in this entire class is gonna be one of the bonus questions. I don't know if I'm gonna have another bonus question, because this has already got a bonus question in it. I might just have one bonus question. At the end, in addition to the known one. People are still writing, so I will wait a second. A lot of people showed up today. I told you guys I had jury duty, right? This is the fucking best thing ever, ever in my life. This has never happened before. It wasn't last Friday, it might have been last Friday. It had been last Friday, it's been a week. Last Friday, I'm driving home from the school. I'm over in Visalia driving home, and I get a call from Porterville. I'm like, my wife's family's in Porterville. No one's calling me, none of them fucking call me. They'll call my wife first. So I answer and they, hello, this is Porterville County, Porterville Court, Collier County Court. Is this David Jones? I said, yes. Did you get jury summons? I said, yes. And said, when you can, check it. And if it says 2023, it's valid. But if it says 2022, it's from last year, and we accidentally sent out some jury summons from last year. And so, and she says, if it is 2022, this doesn't make you exempt from jury duty for the year. Because once you've been summoned and you go in, like, it just means it was a bad paper, it doesn't count. And that's what it ended up being. It was the 2022 jury summons. I get to just throw it away, and I'm like, sweet. They called me to cancel jury duty. This is the best ever. Never happened before. It's glorious.
Then I have them called every year.
Do you?
After the state year. Really long.
I like doing jury duty. I like doing jury duty, but they always manage. I have like literally 3 months of the year off. Time for Easter, time for spring, or all of summer. I've got winter break. There's so many days off I have. When do I get called? It's always right during the middle of a semester. I like it because it's fun. I don't know, convicting people. I don't know. You're an evil fucker. I don't know.
One day, they always excuse me.
I've been excused most of the time that I've been summoned. All right, number 9, solve the following system. Y equals x squared minus 2x plus 1. X minus 3y equals -1. So, what can we do? Do this? Okay, I can do that. That seems valid. I will distribute. And I'm gonna move the -1 over by adding it to both sides real quick too. So if I put this shit all together. And you know what? I really absolutely detest having a negative number in front. So what I'm gonna do is I'm gonna just multiply through by a -1. And that just changes the signs of everything. It's gotta be at least 90% less likely to make a mistake if I have a positive coefficient. If I have a negative coefficient in front, it's just, I don't know. Maybe you're a better man than me or a woman than I am, or. But I like writing numbers positive. So now that I'm here, I can factor. I need things that multiply to 6 and add to -7. That's gotta be -1 and -6. So. I do the factoring. So I set each equal to 0. And I get x equals 2 or x equals 1/3. What do I do with that? We could take this and plug it back into either one. You want to plug it into the y? That's what you. I don't have a problem doing that. Is that what you want? Is that what you meant?
Sure.
Did you mean the other one?
No, the other one. Because the Y is already by itself.
Let's see, let's check both. I think doing the one with the square, doing the whole number is probably easier than this one. Because that's pretty easy. Four minus 4 plus 1 is 1. And this went with x equals 2. So that set is giving me a 2, 1. Now, when I do the x equals 1/3, and I don't want to square 1/3, so I'm probably going to plug it into the other one. 1/3 minus 3y equals -1. I will multiply through by 3, just because I don't like dealing with fractions. I'm sure I'm going to have a fraction at the end. And I am, it's going to be an ugly fraction. And that was when x equals 1/3. I have two answers. Do they both work? Let's check. Let's check the answer there. Let's plug it in. Does 1 equal 2 squared minus 2 times 2 plus 1? Yeah, that's the one we actually found it with. We also need to check it in the other one. 2 and 1 into x minus 3y. 2 minus 3 times 1. Does that equal -1? Yeah, that one works. So that one is valid. Now the other one's going to be the bitch to check, right? I've got 4/9. Does that equal 1/3 squared minus 2 times 1/3 plus 1, 1? Well, this is going to give me a 9. I'm going to need these in terms of 9 on the bottom. I'm going to go through and I'm going to multiply this by 3/3. That way I get a denominator of 9. And I'm going to multiply this by 9/9, and I'll get a denominator of 9. That might make things a little bit easier on the next step. 1/3 squared is 1/9. And I've got -2 times 1 times 3 is -6 on top. over 9. And then I've got plus 9 over 9. So I have -6 or -5 plus 9 over 9 is 4/9. I did get it. It did work. It wasn't fun to do, but it worked. And we'll plug it into the x minus 3y equals -1. I've got 1/3 minus 3 times 4/9. Does that equal -1? This is 1/3 minus 4/3. Because 9 is 3 times 3, and I can cancel a 3. And that does equal -1. So 2, 1, and 1/3, 4/9 are solutions. Not fun, right? Sucks having that. That's a crappy answer. 1/3 and 4/9. It worked though. It was not fun plugging it in. We got one more equation and we've got one more conic section we have not done yet. So our final questions on that conic section. All right, I don't see any pins moving anymore. We will continue. All right, find the eccentricity and foci. For this thing, when we have eccentricity and foci, this was either hyperbola or ellipses. Don't let the fact that we already did the hyperbola one automatically eliminate it. We should just check. This is an ellipse, why? There's a plus sign here, and this is a squared, and this is a squared. So yes, this is definitely going to be an ellipse. So what do I need to do to graph this bad boy? Center, how do I find the center? Center is a great start. It's gonna close, it'll be the 1. It's the opposite sign. Remember opposite sign, -2 for center. What is the 36 and the 9? What is that?
And
Well, it's close to my A and B.
it's
It's my A squared and my B squared. So which one is the A squared? A squared is 36, so that makes A 6. And B is 3. Let's go start plotting that shit. A is 6 means I got a lot of motion going on here. I'm gonna need it wider than I have it tall. All right, I'm gonna put my center down right where I said it was, 1, -2. What do I do with the A and the B?
like 6.
I go to the right 6, 1, 2, 3, 4, 5, 6. I go to the left 6, 1, 2, 3, 4, 5, 6. And the 3 says go up 3 and down 3. Same start that we do with the hyperbola. With the hyperbola though, we make the box, we do the asymptotes. That's not what we do here. Those are actually points on our ellipse. So I am just going to do something that gives it a nice little curvy look as I put it together. It should look roundish. Do not give me some shit like this. That looks like a diamond. That will get you marked down. Just for being too lazy to try to draw a curve. No. Don't do that. All right, so I graphed the ellipse, check. Find the eccentricity and the foci coordinates. How do I do that?
Your foci is a square. Oh no. It's fine.
That happens to work here. Only because A is bigger than B. Only it's the absolute value. But that means I have 36 minus 9 is 27. So C is the square root of 27. Which is, I don't know, about 5.2. So how does that give me the foci?
You go 5.2.
I go 5.2 or C units out from the center. In what direction? Along the major axis, the long length. Notice, if you fuck this up, there's a good chance you'll put it outside the ellipse. In this case, it would definitely go outside the ellipse. Sometimes, like if it's like really close, if this was like 5 and 4, you may not go outside the ellipse. But here, I would go outside the ellipse if I tried to go up. And in the ellipse, the foci are inside it. So going all the way to the right was 6, 5.2 is just a little bit short of going all the way to the right. So maybe that's F2. And over here is F1. So my foci, I put F1. How do I put the coordinate? Both of them have the same Y value, right? The Y value is not changing. That's got to be the same as the center.
Negative square root 7.
Yes. And the other one is 1 plus square root of 27, negative 2. How do I find the eccentricity? E equals C over the value on the major axis, which is A here, right? It's going to be square root of 27 over 6. I'll put that here so I can box them all together. All right, so I did my graph. I've got my eccentricity. I've got my foci. State the domain and range. What is the domain and what is the range? Yes.
negative x.
Yes. So the easy way to go about doing this for the domain is you're gonna do h plus or minus c. And for the range on the ellipse, you're gonna do k. Not c. A. Plus or minus a. And k plus or minus b. For the range. Now I have the domain and range stated. I'll put a box around these because I conveniently put them all in one spot for Mr. Jones to find. I feel like even though we went over this slowly in class, we still didn't use all the time. I feel like I didn't give you guys enough questions on this. Maybe I should go home and add more. I don't want to grade more. Trust in my laziness to keep the test nice and short. That's enough to test you on a lot of the concepts we did this semester. Any questions? There will be one additional bonus question. If you've been paying attention to me at all during the semester, you know what topic I like. And it was not on the test. And that will be what your bonus question is, so practice that. I'm not gonna tell you. But is there any theories on what it is? Kind of curious. Anyone have an idea what the bonus is gonna be on? I'm not gonna confirm or deny. I just want to see if there's any ideas.
D&D.
That's a great one. You're the only one that's probably gonna do well on it though. Oh, did anyone else play D&D? Yeah, I can't do that one. I like it though.
What fraction decomposition?
There's a theory. Any other theories? I think that's, you agree? What? Oh, wow, she's even got the section. Any other ideas? Is that the only ideas you got? It's so much fun shit. There's nothing else you think I would find more fun than that? All right, we're done either way. I will see you guys on Tuesday. The support course starts at 2 o'clock, so if you're available at 2, you can come at 2. And you'll have till 5, no matter what time you get here. Because I have another class at 5 that I gotta go do, so. If you're here at 2 or if you're here at 3, you'll have until 5. I will see you Tuesday. Godspeed. That's never a good word. You hear Godspeed, there's a good chance you're gonna die.
Die, take the final.
Right?
Have a good day.
You too.